Hello everyone, this is the fourth lecture on organic chemistry, and in this lecture we will discuss hydrocarbons. As you know, according to definition of hydrocarbons, the compounds containing hydrogen and carbon only are called hydrocarbons. And hydrocarbons are classified into two categories. One is saturated hydrocarbons and other is unsaturated hydrocarbons. So the hydrocarbons in which there are only single bonds between carbon atoms are known as saturated hydrocarbons, but if there are multiple bonds, that is double bond or triple bonds between carbon atoms, then those hydrocarbons are known as unsaturated hydrocarbons. Now, saturated hydrocarbons, because there are only single bonds between carbon atoms in saturated hydrocarbons, and such hydrocarbons are called alkanes. So alkanes are saturated hydrocarbons, while if there are double bonds between carbon atoms, these are called alkenes. So in alkenes there is double bond, and in alkynes there is triple bond. So if there is a double bond between carbon atoms, these are called alkenes, and if there is a triple bond between carbon atoms, two carbon atoms, then the hydrocarbon will be called alkyne. Now, alkenes and alkynes are unsaturated hydrocarbons, but alkanes are saturated hydrocarbons. So we will discuss only alkanes in this lecture. There are so many other differences between alkanes and alkynes, and one of the most important difference that we have not discussed yet, that we are going to discuss, that is the chemical reactivity. If we talk about alkanes are also called paraffins. Alkanes are also known as paraffins. So paraffins, it stands for low affinity. Paraffins stands for low affinity. As I told you, there are only single bonds between carbon atoms. So if there are only single bonds between carbon atoms, then the carbon atoms cannot undergo addition reaction. So therefore, since the saturated hydrocarbons, or you can say alkanes, have very low affinity for a reaction, means they are very less reactive, that's why they are also known as paraffins. While if we talk about alkenes and alkynes, because there is a double bond between carbon atoms, so or triple bond between carbon atoms, so they can undergo easily addition reaction. So they can have addition reaction. Alkenes and alkynes can have addition reactions, but alkanes cannot have addition reaction. So I hope you have understood the difference between the chemical reactivity of alkanes and alkynes. Now let's talk about alkanes only. So if we talk about the alkanes, you know that the general formula of alkanes is CnH2n plus 2, where n denotes a natural number. The value of n starts from 1, then 2, 3, 4, then these are called alkanes, and we have already discussed the nomenclature of alkanes. So if we write the name of the compound, so if there is the value of n is 1, then the formula is CH4, it will be called methane, C2H6, ethane, then propane, butane, so it ends with ane. So alkanes are named according to the word alkane. So it is used for the number of carbon atoms, meth, eth, prop, but, and then ane is used as a primary suffix because there are only single bonds. So I hope you have understood the nomenclature of alkanes. Now the next topic is source. So we have already discussed about nomenclature. For example, if it is CH4, what is the name of compound? Methane. If C2H6, it is called ethane. Then C3H8, it is called propane. Then C4H10, butane, and so on. Now if we talk about the source, the main source of alkanes is natural gas and petroleum products. So generally alkanes are obtained from natural gas and petroleum products. For example, methane, ethane, propane, these gases are obtained in natural gas, while the other higher alkanes can also be obtained in petroleum products. So these are the sources of alkanes. Alkanes can also be found from the coal pockets. Now the next topic is preparation of methane and ethane. So in this lecture, we will mainly focus on two compounds. The first is methane and second is ethane. You know what is the formula of methane? That is CH4, and the formula of ethane is C2H6. So we will be talking about methane and ethane only. Now we are talking about the preparation of methane and ethane. So there are so many methods of preparation. Now if you talk about the laboratory preparation of methane and ethane. So for methane we use sodium acetate. So it is sodium acetate, and sodium acetate is treated with soda lime. Remember, sodium acetate is treated with soda lime. Now what is soda lime? You have to remember it that soda lime is the mixture of NaOH and CaO. So the mixture of NaOH, caustic soda, and CaO, that is called quicklime. So its combination is known as soda lime. So you can see it is treated with NaOH and calcium oxide. So on heating sodium acetate with soda lime, what will we obtain? We will obtain methane and sodium carbonate. You can see here. So CH3 will combine, this CH3 will combine with this H, while this Na and CO3. So it will form Na2CO3. So this is how we can form methane. Now if we want to form ethane by laboratory method, so what will we use instead of sodium acetate? We will use sodium propionate. We will use sodium propionate. So sodium propionate is again treated with soda lime, and what will we will get? We will get ethane along with sodium carbonate in the same way. So this is how we can prepare methane and ethane in laboratory. The next is general methods of preparation, other methods of preparation. So if you want to prepare methane, we can react iodomethane. This is iodomethane because iodine is attached to it. It is called iodomethane. So iodomethane is treated with zinc copper couple and alcohol. So this is zinc copper couple and alcohol. It acts as catalyst and the source of hydrogen. So the nascent hydrogen, this is iodomethane, and this is nascent hydrogen. So nascent hydrogen gives you CH4, that is methane and hydrogen iodide. So this is how we can prepare methane. Now if you want to prepare ethane, what will we use? We will use bromoethane. We will use bromoethane along with nascent oxygen, in same way zinc copper couple and alcohol, and we will get ethane and hydrogen bromide. So this bromine will combine with one hydrogen, and one hydrogen will replace the bromine atom. So this is how we can prepare ethane. There is one more way of preparation of ethane. Actually there are so many ways, but we will be discussing only important ones. So this reaction is called Wood's reaction. This reaction is called Wood's reaction. So what happens in Wood's reaction? In Wood's reaction, iodomethane, you can see here, iodomethane is treated with sodium metal. So instead of iodomethane, you can also use bromomethane or chloromethane. So iodomethane is treated with sodium in the presence of ether, and what will we get? C2H6 plus sodium iodide. So this is how we can prepare ethane from iodomethane. So I hope you have understood how to prepare methane and ethane by various methods. Next is chemical properties of methane and ethane. So there are so many chemical reactions of methane and ethane. So we will discuss all type of reactions. So first one is substitution reaction. So first of all, we have to understand what are the substitution reactions. So as the name suggests, substitution. If any of the hydrogen atom from alkanes is replaced by any other atom or group, then it is known as substitution reaction. So substitution means a hydrogen atom is substituted by any other atom or group of atoms. So this type of reactions are known as substitution reactions. So if the substitution takes place by chlorine, then such reactions are called chlorination. These type of reactions are known as chlorination. If instead of chlorine, if we use bromine, then it will be called bromination. If we use fluorine, then it will be called fluorination. So chlorination can be done by heating methane and ethane or by diffuse sunlight. In the presence of diffuse sunlight, methane will react with chlorine and one hydrogen atom, see here, one hydrogen atom will be replaced by chlorine atom. So it will become CH3Cl. So there are two chlorine atoms in Cl2. So the hydrogen atom that is replaced will combine with other chlorine atom and it will form HCl. And it keeps going on. This process keeps going on until there is no hydrogen atom. So after that, again CH3Cl will react with chlorine in diffuse sunlight or by heating, and it will form one more hydrogen atom is replaced by chlorine. So the hydrogen atom that is replaced will combine with other chlorine atoms. So it will form CH2Cl2 plus HCl. Now this is called chloromethane. This compound is known as chloromethane. There are two chlorine atoms, so therefore it will be called dichloromethane. Similarly, CH2Cl2 will combine with one more chlorine molecule in diffuse sunlight or on heating. It will form CHCl3. This compound is known as trichloromethane, or its common name which is used mostly is known as chloroform. So I hope you have heard the name of chloroform and HCl. Then further, because one more hydrogen atom is there, so it can also be replaced by chlorine atom. So this hydrogen atom is also replaced by chlorine atom on reaction with diffuse sunlight or on heating. So it will form CCl4, that is tetrachloro, because there are 4 chlorine atoms, so it is called tetrachloromethane, or it is also called carbon tetrachloride. So it is carbon tetrachloride and HCl. So this is how the substitution reactions take place. Now similarly, if the substitution takes place in ethane molecule, so what will happen? Chlorine will react, same, the conditions are same, diffuse sunlight or on heating. So first one chlorine atom will be replaced, so it will form chloroethane, monochloroethane, or you can just say it chloroethane plus HCl. Similarly, one more hydrogen atom will be replaced, so it will become C2H4 and chlorine will take place, so it will become C2H4Cl plus HCl. So it will be called dichloroethane. One more hydrogen atom is replaced by chlorine on reaction in the presence of diffuse sunlight or on heating. It will form C2H3Cl3, that is trichloroethane plus HCl. One more chlorine atom is taking place of hydrogen atom, so it will form tetrachloroethane. There are 2 hydrogen atoms there, so one more hydrogen atoms can be replaced by chlorine, so it will form pentachloroethane. Similarly, one hydrogen atom is remaining, so it can also be replaced by chlorine, so it will form hexachloroethane. So this is how this type of substitution reactions will take place, and such reactions are known as chlorination because they are being replaced by chlorine. So if they are replaced by other groups, for example bromine, then it will be called bromination. Now the next type of reaction that we are going to discuss is oxidation. So in oxidation, first we will talk about combustion. So combustion takes place by reaction of CH4, methane or ethane with air. So oxygen present in air will react with methane or ethane and it will give the product as carbon dioxide and water. The product is always, whenever the hydrocarbons are burnt, they will give water and carbon dioxide. So when complete oxidation is done, complete oxidation means in the presence of excess of air, we have excess of air. So in the presence of excess of air, it will give carbon dioxide and water. So this is called complete combustion. So these are the combustion reactions. So CH4 plus 2O2 will give CO2 plus 2H2O. Similarly, 2C2H6, that is ethane plus O2, 7O2 will give 4CO2 plus 6H2O. Similarly, we have incomplete combustion. So if combustion is not completed, if it is incomplete, so in the limited supply of oxygen, if oxygen is not enough, so methane on reaction with oxygen will give CO, that is carbon monoxide, not carbon dioxide, and water. And if there is very limited supply of air, for example CH4 plus O2, the very limited supply of air, so you will get carbon plus 2H2O. So you will get carbon only. Now similarly, if ethane reacts with oxygen in limited supply, it will again form carbon monoxide and water, and if the oxygen is present in very limited, it will form carbon and water. So this is how ethane and methane reacts with oxygen by combustion. So if combustion takes place in excess of air, then reaction will be different, while if it takes place in limited supply of air, the reaction will be different. It will give carbon monoxide and water. So you have to remember these reactions. Now the next is catalytic oxidation. You can see in these reactions there is symbol of heat. So you know that on combustion a large amount of heat is also produced. Now if we talk about catalytic oxidation, it means for oxidation we use some catalyst. For example, if the reaction of methane with oxygen is done in the presence of copper, so copper is used as catalyst, so we use a copper tube at 200 degrees Celsius, it will form an alcohol. So what is this? This is methanol. It forms methanol, or it is also called, common name of methanol is methyl alcohol. Similarly, if ethane reacts with oxygen in the presence of catalyst, catalyst is copper tube, so it will form ethanol. It is called ethanol or ethyl alcohol. Now remember, on further oxidation of methanol, so oxidation of methanol will give HCHO. This is called formaldehyde. It is called formaldehyde. And on reaction of formaldehyde, on further oxidation of formaldehyde, you will get formic acid. So it is formic acid. So it means on oxidation of methane you get alcohol, that is methyl alcohol. Then oxidation of methyl alcohol will give formaldehyde, oxidation of formaldehyde will give you formic acid. Similarly, oxidation of ethyl alcohol or ethanol will give you, this is called acetaldehyde, and oxidation, on further oxidation of acetaldehyde will give you acetic acid. So you can see the trend here. Similarly, CH4, that is methane, on reaction with oxygen in the presence of molybdenum oxide at 350 to 500 degrees Celsius. So this is other type of reaction. It is directly converted to, this is formaldehyde. Similarly, ethane on reaction with oxygen with the catalyst molybdenum oxide at 350 to 500 degrees Celsius, it will form acetaldehyde. Now you can see the trend here. First, alkane is oxidized to alcohol. You have to use a suitable oxidizing agent. For example, if we are using K2Cr2O7, K2Cr2O7, that is potassium dichromate. So if you use potassium dichromate as an oxidizing agent, alkane will be oxidized to form alcohols. Then alcohols are oxidized and they will give aldehydes, and aldehydes will oxidize to give carboxylic acid. So you can see the trend from here. This is methane, that is alkane, to alcohol, then alcohol to aldehyde, CHO group, you can recognize it, then CHO, that is aldehyde. Aldehyde will give you a carboxylic acid. So this is how the reaction will take place. The last type of reactions, such reactions are known as pyrolysis. These type of reactions are called pyrolysis. So what are pyrolysis? On heating alkanes in the absence of air. So when alkanes are heated in the absence of air, they undergo decomposition. They are decomposed to give other compounds. Such reactions are known as pyrolysis. This process is called pyrolysis. This process is also known as cracking of hydrocarbons. So cracking of hydrocarbons will give you other hydrocarbons. So you can see the example. For example, CH4, that is methane at 1500 degrees Celsius. So 2 molecules of methane will give 1 molecule of ethane. It is 1 molecule of ethane. So this is ethane. Similarly, C2H6, that is ethane. Ethane at 500 degrees Celsius. Aluminum oxide is used as a catalyst here. So it will give ethene and hydrogen. So this is how the pyrolysis will take place. So these are some chemical properties of methane and ethane. Let's see what are the uses of methane and ethane. So you can see various chemical reactions. So you can see here methane is used to prepare chloroform. So chloroform is a very good solvent for organic compounds, as well as it is also used as an anesthesia. Next, you can also see there are so many other examples, like it is used to prepare methanol. So methanol and ethane will give you ethanol. So we can also prepare methanol from methane or ethanol from ethane. So it is used for manufacture of methanol or ethanol. Now methanol is also used as a very good solvent. Similarly, ethanol is also used a very good solvent for organic compounds. Now there are so many more uses that they are used for formaldehyde. So formaldehyde is also used as an antiseptic. Similarly, formic acid is also prepared. Now then acetaldehyde and acetic acid can also be prepared from ethane. So these are some uses. Now one of the most important uses is as a fuel. The hydrocarbons are very good fuels. So methane and ethane is also used as a fuel. So these are the uses of methane and ethane. So this is all in this lecture. With this, our alkane portion is completed. In next lecture we will discuss alkenes. So if you have any queries, you can ask your questions in comments. Thank you very much.